The average length of an investment in realty is 35 months. A random sample of 40 investments indicated a mean of 28 months. Assume sigma equals 9 months. At alpha equals 0.04, is there sufficient evidence to conclude the average investment is shorter than 35 months? All right, so our first step is to identify the null hypothesis, alternative hypothesis, and the claim. So the null hypothesis is H naught, and that's going to be that the mean is equal to something in this case. In this case, they're saying the average length is 35 months. No sample size or anything attached to this. This is just a statement they're making. So this is that the mean, population mean, is 35. The alternative hypothesis, it's either going to be that it's not this, or we're going to have something more specific about it. So if we look here at the end, it says to conclude the average investment is shorter than 35 months. So we think it's shorter. That's our alternative. So we say that the mean, you know what? It's actually less than 35. Or 35 is bigger than the mean. It's not actually 35. Now we need to identify the claim. The claim has to do with the words, usually there's the words conclude in a problem, but it's whatever we're trying to say. And so here we want to conclude the average investment is shorter. So we say that the alternative is the claim. It's usually the case that this is the claim for most problems, but the null can be the claim. So be careful. The null can totally be the claim. Also, while we're here, we can look at this sign here and we can tell that it's a one-tail test. One tail. And it's less than, so it's left-tailed. So the sign tells us that, or the inequality, I should say. All right, up next, let's get all the numbers out of the problem. So let's just start at the beginning. Average length is 35 months. So we have that mu is equal to 35. We're told a random sample of 40. So that's n. We've got 40. And a mean of 28 months. So an x bar of 28. After that, we assume sigma is 9 months. So sigma is 9 months. And we've given, this is a bit of a strange alpha, 0.04. It's not one of the standard ones, so that'll be interesting to do. And is there evidence to include the investment is shorter? Okay, so we got everything that we need. So from here, we can do this two ways. We need to find our test stat, or we can use the p-value method in the calculator and all that. So let's find the test stat via the formula first, then we'll do it with the calculator method. So the test stat is going to be given by a formula. If you don't have it memorized, you could always go look it up. It's a z-test. Okay, so it's a z-test because we are given sigma. So z. And our sample size is 40, which is greater than 30. And it is, because of that, normally we also like to see the words that the distribution is normally distributed, which those words aren't included here, but we have a large sample size and we know the population standard deviation. So we're going to use a z-test, and that's going to be x bar minus the mean over sigma divided by the square root of n. So x bar is 28, mean mu is 35, sigma is 9, and n is 40. Plugging this into the calculator, let's pull that up. Some number, let's plug it in. So I'm going to use the fraction capabilities. 28 minus 35 over 9 divided by the square root of 40. We get out, holy smokes, that's big for a z-score, 4.92. I can tell you right now, we are going to be rejecting just, and 3 is very large. 4 is like, well, this is basically 5. That's huge. So, okay, this is not even on the chart. It's that big. So the area to the left, the p-value, I can tell you right now, is going to be 0-ish, somewhere around there. You might be going, how can you tell all this stuff just by looking at this number? So if we were to look at the table of 4.92, it's not even on here. The biggest we go is negative 3.9. And look at the area. It's 0.000. How many zeros? 4 zeros and then a 5. And so when you get past this, like we're almost at 5, that's basically going to be 0, like incredibly small. So, and the calculator will show this too. So let's do this with the calculator as well. We'll get a more specific answer out of the calculator. But we'll have so many zeros that it's basically just 0. So if we go to the stat tests, z-test, number 1, for mu naught, well, what do we got here? We got 35. For sigma, we got 9. For x bar, we have 28. N, we have 40. And, okay, so we'll figure out about alpha later. So mu, we're saying that mu is that our mean, which would be, so here we write everything in terms of mu naught, but here calculator is a bit different. So we just match our sign as long as you write them with mu on this side. So we're saying that the mean is less than 35. So we want less than. And then we're going to hit calculate. If you hit draw, you'll also get a p-value, but it'll be rounded a lot more than the one in calculate will. So let's use calculate. All right. So we get z of negative 4.92 approximately, right, if we round. And our p-value has e to the negative 7 on it, which means that there's 6 zeros and then a 4. So that is basically 0. This is a super, super, super teeny number. So as we can see, that is our result. Already we could tell we're going to be rejecting the null hypothesis. You can also tell just based off of the sample mean. This sample mean is so small. Our study produced a way lower value than the population mean that we were told is. Like it says 35 is 28. This is quite a large difference. If sigma was bigger, this might have been an okay distance, but I mean, this is quite large. So let's go ahead and draw our chart now. So we're going to just go ahead, draw the chart. Something like that. We got in the middle is 0. Keep in mind, this is a z-score chart. It's a standard normal chart. So our sigma is equal to 1 and our mean is equal to 0. So we're going to have a shaded region. Oh, I'm so used to 2 tails. And so we only care about the smaller region. So our alpha, we're told, alpha is equal to 0.04, level of significance. So that means that 0.04 is the area contained in this. 4% of the curve is over here. So we need to find the z-score that goes with it. That's going to be the critical value. You could use the calculator to do this, and I'll show the chart. So if we go to stat, then we go over to, not stat, we don't want to go to stat. This has to do with the distribution, right? So we need to go to the distribution menus. So that's under the blue distribution. So we're going to go to second distribution. We want to give it an area and get a z-score out. So we're going to go to option 3, inverse normal. And it asks for an area. We give it the area as 0.04. And then remember, mean is 0, standard deviation is 1, as we wrote here already. Because we're dealing with z-scores, and this is a standard normal curve. This is the whole point of the formula we use too. So we're going to go over to paste it in. We get a critical value of negative 1.75. Now, we can also find this on the chart by looking up an area of 0.04 and seeing what z-score goes with it. So the area is 0.04, so let's go to the chart right here. We're going to look at for 0.04. And my calculator is always a bit in the way when I do this, but bear with me. So let's see here. What is the closest to 0.04? So right here, we've got 0.04006, and that is pretty dang close compared to the other ones here. So we're going to go with that one. Doesn't have to be totally exact, but we see that goes with negative 1.7. If we go up to the top, 5. So if you did it by the chart, you go with negative 1.75. If you went with 6 or 4 also, it'd be fine. You'd be really, really close. But if you use the calculator, you can get an exact value out, and you can see with the calculator, we got negative 1.75, which would agree with what we would do with the chart. So knowing our critical value, now we can go ahead and plot the test stat. Our test stat is negative 4.92, which is like, if this is 1.75, it'd be like way back here, negative 4.92. If our chart were to continue, this kept getting smaller and smaller and smaller. And the p-value would be this itsy bitsy area way back here, which is essentially approximately 0. You saw it wasn't, there is a value it is, but it's very, very, very small. And so drawing the conclusion, we'd say, well, we would say that you could do the p-value conclusion or the test stat. So test stat's clearly in the shaded region, so we reject the null hypothesis. Because the null hypothesis is represented by the unshaded region, right? And we're definitely not in that. The other thing we can say also with the p-value is that the alpha, right, that's 0.04, is way bigger than the p-value. And all this is saying is, it's the same thing as the test stat. It's saying that the shaded region that the p-value has is smaller than alpha, indicating that it's in the shaded region. It's really far away from the null hypothesis. So we would say, again, reject the null hypothesis so that you could justify it either way. So if we reject the null, that means we don't think this is true. We think the null hypothesis is false, which means that we think the alternative is true. The alternative is our claim. So we have evidence to support that this thing is indeed the truth because we did a study, right? So we'd say there is evidence, our study specifically, evidence to support the claim. And then we would go on to attach it to the problem. So we'd say to support the claim that, and let's see here, what's our thing about that? The average investment is shorter than 35 months. Just write the end of that sentence there. Most of the time, it's just the last sentence will have what you need. Sometimes the claim will be put somewhere at the beginning or in the middle. It's usually at the end though. So just tie it up with the problem so that people know what the conclusion is. So we'd say, yeah, we conclude that it's not 35 months, that it is indeed, according to our study, we have evidence to conclude the average investment is shorter than 35 months. And that's all you do to do a problem like this. So not too crazy of a problem. If you have any questions about this, feel free to let me know down in the comments. Subscribe and hit that bell icon, and we'll catch you in the next problem.